just leave it on. Just okay.
Yeah, but that's not actively participating in the group meeting.
You will be participating. Just come back when you can, but just so we at least have you in here, okay? All right. So I don't want to do that whole calculation again, but
No, okay.
0.0059. So we go back to the.
Can you just say what you put in, what numbers you plugged in? Because I
Of course.
still got something different.
So the point.
So this is what I did. Just tell me if
Okay.
I'm wrong. On top, I did 40.0476 minus 40. And then
Yes.
on bottom, that's divided by 36.35585. Oh, that's what I did. I hope that's the one. I accidentally I accidentally put minus instead of divided by.
Yeah.
Which would make a huge difference. Okay, now I got it. Okay, you're good. Now I got it.
All right. So you got 0.00599.
Yeah.
All right. So we take that number and go to our normal probability applet, and so that's our t-score, 0.00599. And wow. So that's crazy. So it's shown me a p-score of 0.5024.
So you plug that 0.00599 into the z-score?
Yeah, into the z-score, because it's t-score and z-score are basically the same thing. Just
Yeah, and
the
the
t-score
P is the area?
Yeah, p is your area. So
And
it's not just your area; it's also your percentage. It's your
yeah, but like that's what it's coming up on the probability applet as.
right. So 0.5024.
I didn't get that. Mine looks weird. Mine has only one red line right down the middle.
And then you gotta highlight the negative side of that.
But then it ends up being 0.49 for me.
Hey, Matt, do you have it up? Could you just screen share it?
Okay.
Does that make sense?
Yeah.
It's the green button on the left there. Sorry to interrupt. I was just thinking that might be helpful so I
No,
can see
you're
it.
good. That would be helpful.
Should be. There we go. So I went to my p-score.
Okay.
Here we
Might
go.
work.
And I put in this number and here, and it pretty much rounded it up to the 0.006 because I don't think the z-score goes any lower than that. So then I just highlighted the negative side. And
That's so weird because mine's what is yours? What numbers is it reading? I can't read it.
it says 0.5024.
Because I did the same thing, put 0.006 in, and I put 599 and it put it to 0.006, and mine is highlighting 0.4976. I don't understand why. Mine doesn't even have two red lines like yours does.
Yeah, well, I just...
Look, you put 059. It's 005.
Yeah, it rounds it up to 006.
Still have 0.5. That's so weird. I don't know why we have different things.
It's crazy. So I put that 0.5024. And then it says round to 3 decimal places, so it'd be 0.502. Boom. What decision do you make? Well, it's less or minus. This needs to be over 0.001, so we fail to reject. Boom.
Well, actually, it's not my
you decide to try another with a 40, keep the same level of significance, did your p-value increase or decrease?
I put decrease. I was confused. I don't know if I did it right. Well, I was doing it based on what I thought I should do for 11, and I did not do 11 right.
Oh, there we go.
That's gonna be fast.
No.
Two or three. Pretty quick.
So this one here has the same exact example of what we're doing with it's less than, and it's saying it does decrease. So anybody still there?
Yeah.
So decreases is what I'm putting.
Yeah, I put that too.
Okay.
I don't understand why. I put it earlier based on what I thought should do for 11, but I was wrong on that. So now I don't know why. But I saw decrease. I'll have to go figure that out. So then I put for 14 I would reject. No.
Let's see what they do in this one example really quick.
But there's not enough information. If it is decrease, it could decrease, like, I don't know, by how much would it decrease?
If it decreased past 0.01, then we would have to reject it. So.
No, but we don't know how far it's decreasing. We just think it's decreasing. So, it could decrease like 0.3 or something. So there's not enough information in that, which makes me think maybe it's not decreased. That doesn't make sense.
Mm-hmm. That does make sense, but there's not enough information really to.
Yeah.
Oh, actually, on one second on this sample.
Would be much better. So that would be 7.
I'm not finding anything. So, okay, so in the reading, it says, in the, what's it called? SPSS thing.
Mm-hmm.
Have that chart that tells you what T is and what the DF is, and then have a little chart thing.
Yeah, well, DF is the sample size minus 1.
Yeah,
But
but
I don't
so
really
you-
understand, because the higher that the DF goes, the more it gets closer to
yeah.
the normal, or the...
So we'll scroll down really quick to in the reading, just a little bit to that blue SPSS instructions. Keep going. Right there. So you go down there. It says, I think it's where at like the very bottom of your screen. It's saying alternative hypothesis. Well, no. Keep going down. That right there. So when it says not equal to 98.6, it says the p-value in the area is equal to it. And then when it says it's less than, pretty much what you do is you simply divide that same number by 2. So it would have to be smaller. So if you divided what number we got by 2, you know, I think you would still fail to reject. Does that make sense at all?
Nah, it doesn't to me, but I think you're on the right track. So I think you...
right there, what it's saying, do you see what it says, that number, let me go back to the reading. So the sig two-tailed number is 0.000, right?
Yeah.
And so then when that first bullet point says the p-value in the area is the area in the two tails in both tails. That's what the p-value is. And so, no, but that doesn't make sense because we did just one tail. I don't know. I don't know.
It's usually that's what those are not.
Should have made a bargain before you went. Whether it's soda. We could have.
In the reading right there, it's telling us to find the p-value from SPSS. But it's very, very small.
Matt, you should tell your party people to keep it down.
Just stand up and embarrass everybody.
Because for one,
Okay, I'm gonna type in how to find P. Hey, honestly, I think what we were supposed to do for the p-value, hold on.
Oh yeah, it goes fast.
I feel like it's both sides. That's really nice.
Yeah, she put like probably this is two That's your solution. Yes.
Sneeze here. 1 second. Sorry.
You're good. Okay, how do we know if this is a one-tailed or a two-tailed hypothesis?
That's on the lesson ago.
I think it's two-tailed because it's just saying that it's not equal to, you know?
Yeah.
It's not saying less than or greater than.
So you're saying number
I think we did something
11
wrong.
is two-tailed, is what you're saying.
Yeah, so it wouldn't be 0.502, you know?
Well, 11 is 502. Oh, I see what you're saying. So if it's both sides, it would be
More than one.
It would be one,
So,
like, but you can't have.
Which doesn't make sense. So, which makes me think we didn't do it. So, where did you find that you plug the t-score into the z-score, and then the top is the p-score or whatever p-value? I'm not finding that anywhere. I'm not doubting you. I just can't find it.
So why would
I actually have something I found on here. Is find the p-value when you know the t and when you know the df. So let's just use that really quick. See if that helps.
I have that same, not that same one, but a similar one up.
All right. So our p-value, or excuse me, our t-value was. What was that value again? That was
I'll find it again.
0.00599, right?
Yes. Yes.
All right. So 0.0059. I'm gonna put the whole number in there and see what it does. So actually, I'll just do 998. And then DF was our sample size, which, go back to that, I think it was 21. Let me just count the things just to double check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 minus 1 is 20. calculate P. The two-tailed p-value equals 0.9953, which makes sense. That rounded up to 1.
Yeah.
So let's just put that back in there, 0.9953. That definitely does make a lot more sense. So that what that really is doing is it's highlighting both sides, and there is just like a sliver in the middle that is not.
Yeah, but we can't see because it's not accurate enough.
Mm-hmm. And there is a way. Let's see. I can go back to SPSS really quick. There's a way to interpret this data here into that. So let me go back to the reading. I bet it tells us in that reading there. All right. Paste some data in appropriate column A. So the null hypothesis value itself, the example value should be 9.6.
Okay, on the normal probability applet, if you unhighlight everything and then just highlight both sides and then put the 0.006 in, so like I just moved the middle line. I moved the middle line because I didn't realize, but that middle segment for me was highlighted. Does that make sense?
Oh, okay.
So I just moved it, I made it bigger, unhighlighted it, re-put my values in, and then I got 0.995.
Boom, there it is. You're right. Annoying probability applet.
I know.
All right. So now that it is that high, it is above.
So we
is
would
greater,
reject.
so we fail to reject.
Yeah.
Perfect. And then if we do it the other way and we just do the bottom part of it, I'm pretty sure we get the same data, the 0.006. But
we
now,
end up getting 0.4976.
Oh, so oh, I see what you're saying. Yeah. So that
Which
area
is still more.
is still more. So we still fail to reject.
Yeah.
And the value does decrease.
Yes.
All right. Compare the width of the confidence interval for the 11 to the confidence interval of 13, which is wider. So, the confidence. So let's see. This one, they're both at the 1%. So we just did this in our last section on Tuesday. So go back for minus. It's like it is equal to something minus the z divided by or times the standard deviation. And it's plus, remember? And then it's just which one is going to cover the most value.
Okay, let me go pull that up.
Well, that's right.
Okay, yeah. You do x plus or minus z times the standard deviation over the square root of n. So in our case, x is 40.0476 minus the t, which is 0.0057763 times.
So here's a quick question, because pretty much all the data is the same, right, for those two questions. So they would be the same, but the only thing that throws me off is in the second one, we're going from the center and we're doing is less than, so it'd be from the center to that interval instead of from the center to both both ways. Do you see what I'm saying? That's the only difference I see. So is it saying that the one with the less than is less than or thinner, and the one on 11, since it's equal to, it's got both sides, it's double-tailed, it's wider? Do you think that's what it's saying? Because all the other data in this is the same.
Yeah.
So compare the width of both. Which one is wider? I would say 11. Or
That's
they're
what
the
I
same.
said as well, because I'm gonna go. Did you see his email from today?
No.
It gave a lot on confidence intervals, but it didn't really explain this. Okay, let me make sure it doesn't.
Oh, here's towards the bottom here in the reading. Let's see.
Yeah, it does talk about confidence intervals, but okay, I did that. I just barely did those x plus and x minus. So on the x minus that, it ended up being 40 point, just pretty much 40, and then on the x plus it was 40.09. So I don't know which one to attribute the plus to. Is it that they're not equal? That would make sense. Did you catch that at all?
No.
So do you see under confidence intervals on the reading that formula?
Yeah, I see the formulas there.
I just did that formula in my calculator.
Mm-hmm.
And when I did the x minus t s over n, I got 40. And then when I did x plus t s over n, I got 40.09.
Okay. Which?
So 40.09 I think is wider. And I think that would be attributed, that would probably go with the not equal to. Because minus could be less than, but that doesn't, I don't understand that.
When I look at the problem, I see that if we put in the numbers for both 11 and 13, we're going to come with the same inputs and outputs. So we're going to get the same high or maximum and minimum, basically, in the confidence interval. So what I'm saying is either they're going to be the same, like the answer says, they're going to be the same, or the less than sign that we have on number 13 is just saying that it's going to be that right at that thing, or it's going to be less than it. You know what I mean? So it's only going to be this half of. So that's why I want to say it's 11 is bigger because it has both halves, or they're the same thing, and that doesn't even matter that it's less than.
It would make sense that they're the same because look at what you plug into that formula. You plug in x, you plug in the mean, you plug in the standard deviation, and you plug in t. T is the same. P is different, the p-value, but the t is the same.
Exactly.
You're right. So they probably are the same because you don't use p-value in that formula that you're looking at, that we're looking at.
And they both, because another way to look at it too is the DF, the differential value. It's going to be 20 either way, so it's going to be off from the normal bell shape just a little bit lower, so it's going to be wider, but they're both going to be at that wideness. So I would say that they're the same.
Yeah, that makes sense.
All right. Do you want to go over 3 through 10 really quick?
Yeah, let me, I'm trying to do, I did one of them wrong with the one that was asking for the p-value. So I'm trying to plug it in real quick. Let me do it real quick. 28.22 minus
So,
like writing down
question 2. Yeah, so this one is like, they're all combined. It's really annoying. So, oh.
question or
Yeah.
Okay, I'm ready now.
Okay. So number 3, I got. We assume the thing is unknown.
Yes. 4, I said no.
Yeah. 5, I did 1.5.
6, 98.22.
0.
You just put a 0 in?
Yeah, because it says the 3 decimal places. So I just put added a 0 on the end.
Okay.
What is S? Number 7, I got 0.22 or 0.922. Excuse me.
Really, I don't even know how I did that. But I got 0.206. Let me go look. I have that pulled up right now. Oh yeah, it is 0.922. What was I looking at? I don't know.
And then H.
I got 476.407.
I got negative 1.843.
That's also, I also did, the S score was wrong on mine.
All right, so let's just do that problem really quick. So we got,
Okay.
let's see, what is S? So it's 0.922 divided by the square root of our sample size. So 1, 2, 3 is 20. Okay, so let's go 0.922 divided by. I'm doing everything with the computer. So it's 20. The square root of that is that. So we get divided by 4.472359549957 equals that number. So that's our bottom. Our top is this minus this, so we get 98.22 minus 98.6 equals that. So we get a negative right there. We start off with a negative, and then we divide that number by our bottom one, which is 0.02. Shoot, dang it! I don't want to do that one. Back. There we go.
How, so
Point.
the bottom,
Yes.
you just do S divided by square root of N, so it would be 0.922 divided by square root of 20.
Right. And that's this right here.
Okay. Maybe you just said, okay, yeah.
Just go ahead and do it yourself so we make sure that that's the same thing.
Oh, I did. We get the same number. I used, when you were talking out loud, you said 0.02, and I wasn't looking at your...
Yeah, I had to go back and delete that and come back up here, so that's fine.
Okay. I was just listening. I didn't.
I kind of skip numbers sometimes. It's bad, so I had to kind of double check myself. So 61, 65, 46, 75, 25, 4806 equals negative 1. That says 3 decimal places, so 1.843.
So we both got it really wrong.
No, that was the number I had in it.
Oh, okay. I don't even know what I did. Because I had like something in the 400s.
No, you had 4 point something. So you were
420 something point.
Oh, I don't know then what you did.
I have no idea.
And what is the p-value? So the t-score went in there. So let's see, negative 1 point. What did I say? 8.
843.
843. And we're going from the negative side, right? We're going less than it.
Yep.
So it would be
Less than.
0.0327.
No,
Which is rounded.
0.033.
Perfect.
So with this,
That's what I got too.
so
And then what is the correct decision based on this and this? So we were looking at a confidence level of 0.05 and we got 0.03. So we got less than it, so we have to reject the null hypothesis.
Yeah.
All right.
So let's
11.
just run over the last ones just to make sure.
Okay.
So 11.995. 12.
Yeah. One second, I got to delete. Okay. And then, so we failed on 12, and then 13, decrease.
Yep. Then fail, and then same.
Okay. Here, let me
Okay.
submit first. So because I feel like a lot of this, more of this lesson's on me. So let me submit first to make sure everything's right. Okay. All right, I got one wrong.
Which one?
The p-value on number 9 is wrong.
Really?
Yeah, so go back and change that, I guess.
1.843. Okay, I mean, it's not. So, is less than. I don't know what we would do different.
If you look at the top, it is less than it. So it has to be
The left side.
the left side of it.
I wonder if it's the whole left side, including the middle. Because it's everything less than the 1.843. That makes
Yeah,
sense.
but we got negative, remember? We got a negative score on our t-score. It was a negative
Yeah, you're right. Oh,
1.8.
you're right. So that still doesn't make sense.
0.0327 would round to 0.033.
Yeah, I don't know what we did wrong. I feel like we had to have done it right.
Yeah. That's weird. Okay, so I'm going to end the video here, but just keep working on that one and see if you come up with something different. I have to get to me and my wife are going to babysit tonight, so I got to head out.
Okay, sounds
But
good.
I'll post this video on up, and you can just post your reply to it and stuff.
Sounds good. Thank you.
Thank you.
We'll see ya.
Bye.
Bye.